So find the Z parameters for the two-port network in figure given below. So this is the two-port network, and this two-port network has two resistors and one dependent voltage source, current controlled voltage source. So here we can take this two-port network as model 2. So model 1 is two-port network has only resistors, and model 2 is, so along with the resistors, if there is any dependent sources, we are treating that as a model 2 in two-port networks. So here there is a dependent source. So if the two-port network has only resistors or passive elements, so we can say that is a reciprocal network where Z12 equal to Z21, and if it is if there is any dependent sources in the two-port network, then it is a non-reciprocal network. So now we have to get Z12 is not equal to Z21. As the two-port network is not symmetrical, again we have to get Z11 is not equal to Z22. So here let us first try to find out the Z parameters, that is Z11, Z12, Z21 and Z22. First step is Z parameter equations, V1 equal to Z11 I1 plus Z12 I2, equation 1, and the second equation is V2 equal to Z21 I1 plus Z22 I2. So here to solve these parameters Z11, Z12, Z21 and Z22 are Z parameters. So to get Z11 and Z21 we have to make I2 equal to 0, and to get Z12 and Z22 we have to make I1 equal to 0. So first, so solving for Z11 and Z21 by making I2 equal to 0. So solving for Z parameters for I2 equal to 0. So if you keep I2 equal to 0 here in this circuit, so we have to apply that condition to the circuit as well as these equations. If you apply that condition I2 equal to 0 to the circuit, so current in this dependent voltage source is 0. So when the current in this branch is 0, so I1 is the current flowing in 10 ohms as well as in 20 ohms. If I2 is not 0, current in 10 ohms is I1 and current in 20 ohms is I1 plus I2. So current in 20 ohms is I1 plus I2. So current in 10 ohms and 20 ohms are different. But if I2 equal to 0, so if I2 equal to 0, so current in 10 ohms is I1 and the same current is flowing in 20 ohms also, means so 10 ohms and 20 ohms comes in series. So for I2 equal to 0. So for I2 equal to 0, this equation becomes V1 equal to Z11 I1. So Z11 equal to V1 by I1. And similarly equation 2 becomes V2 equal to Z21 I1. So Z21 equal to V2 by I1. So here by applying that condition I2 equal to 0, so the same current, now current in 10 ohms is I1 and current in 20 ohms is also I1, because current in this branch is 0, and port 1 voltage and current is V1 and I1, port 2 voltage is V2 and there is no current. So if you apply KVL, so here we finally we have to get V1 by I1 ratio and V2 by I1 ratio, V2 by I1 ratio and V1 by I1 ratio. So applying KVL in loop 1. So if you apply KVL in loop 1, so we get V1 equal to 10 I1 plus 20 I1. So from that one Z11 equal to V1 by I1 equal to 30 ohms. KVL in loop 2. So KVL in loop 2, if you apply KVL in loop 2, V2 equal to minus 3 I1 plus 20 I1. So we get Z21 equal to V2 by I1 equal to 17 ohms. So by making I2 equal to 0, here we are getting two parameters, Z11 which is equal to 30 ohms and Z21 which is equal to 17 ohms. So similarly, to get the remaining two parameters, we have to make I1 equal to 0. We have to make I1 equal to 0. So if you apply I1 equal to 0, so current in 10 ohm resistor is 0. So we can remove that 10 ohm resistor for the analysis when there is no current I1. So if current is not there in the 10 ohms, we can remove that from the for the analysis of the two-port network. So similarly, equation 1 becomes I1 equal to 0 means V1 equal to Z12 I2, Z12 equal to V1 by I2. And similarly, if I1 equal to 0, V2 equal to Z22 I2, Z22 equal to V2 by I2. So if you apply that condition I1 equal to 0 to the circuit, circuit becomes like this. So 20 ohms, V1 and V2, and current in this is I2. So current is I2, I1 is 0, and here if you see this current I1 is 0, so that's why we removed this 10 ohm resistor. So here also this dependent source value becomes 0. So 3 into I1 is 0, 3 into 0 is 0, 0 volts. So 0 volts means short circuit. So this is a short circuit, and here in this 10 ohm resistor there is no current, so that's why we removed this. So there is only 20 ohm resistor. So voltage across 20 ohms is V1 as well as V2. So current in 20 ohms is I2. So that's why we got the circuit like this. So this is the circuit. So from this circuit now we have to get Z12, which is V1 to I2 ratio. V1 by I2 is Z12. So V1 is the voltage across 20 ohms, and I2 is the current in 20 ohms. So V1 by I2 equal to V1 20, and I2 relation is V1 equal to 20 I2. So V1 by I2 equal to 20 ohms. So similarly, as V1 equal to V2, replace V1 with V2, we get V2 by I2, which is equal to 20 ohms. So Z22 is also 20 ohms. So if you write all the parameters at one place, so Z11 equal to 30 ohms, Z12 equal to 20 ohms, Z21 equal to 17 ohms, and Z22 equal to 20 ohms. So here, based on these Z parameters, we have to comment on the reciprocal and symmetry. So reciprocal. So if Z11, Z12 equal to Z21, the given two-port network is reciprocal, but here Z12 is not equal to Z21. So that's why the given two-port network is not reciprocal. So similarly, if Z11 equal to Z22, the given two-port network is said to be symmetrical. But here Z11 is not equal to Z22. So that's why the given two-port network is not symmetrical. So here next is Z parameter equivalent circuit. So this is the Z parameter equivalent circuit. V1 and I1 are the port 1 voltage and current, and V2, I2 are the port 2 voltages and currents, and V1 equal to Z11 I1, where Z11 equal to 30 ohms plus Z12 I2. So this is the dependent voltage source whose value is Z12 I2. Here it is 20 I2. So similarly, port 2 side Z22 is 20 ohms, and here this is a dependent voltage source whose value is Z21 I1. So where Z21 is 17 I1.